very good morning, everyone. My name is Sai Prasanna, and I am excited to present my internship project on microwave oven simulation. Through this project, I explored embedded systems, microcontrollers, and real time applications. And during my internship, I worked on several fundamental concepts that helped me build this project. Basically, I learned three major topics, that is, introduction to C language, about embedded systems and microcontrollers, and how to implement this project. In C language, I learned conditional statements, loops, operators, array, pointer, function, string, storage classes, preprocessor, and macros. In embedded systems and microcontrollers, I learned about embedded systems, microcontrollers, and basic peripherals. After that, to implement our project, I learned about MPLAB XID, X8 compiler, PixSimLab, and introduction to various peripherals of PIC16FA77A and how to interface them. After that, I learned how to implement our project. And in today presentation, I am going to explain requirements of project, introduction to embedded systems, microcontroller and microprocessor, PixSimLab, LED, switches, matrix keypad, ISR, timer, CLCD, and what is microwave oven, and demo of the project. And coming to basic requirements of our project is MPLAB XID. MPLAB XID is used for developing the code, and X8 compiler, it is used to compile the C code written for the microcontroller, and PixSimLab, it is a simulator tool used to test the system's functionality before actual implementation. In PixSimLab, we are using some components, that is PIC16FA77A microcontroller, CLCD, matrix keypad, timer 2, fan, and buzzer. An embedded system is an combination of hardware and software designed to perform a specific task. And an examples of an embedded system is TV, smartphone, biometrics, smartwatches, smart parking, robots, and refrigerators, electronic gadgets, etc. And embedded system is categorized into four types, that is standalone embedded system, real-time embedded system, networked embedded system, mobile embedded system. And the standalone embedded system means it follows the instruction, it does not question about work. And coming to real-time embedded system, it performs the task within the deadline. It is categorized into three types, that is hard real-time, firm real-time, software real-time. In hard real-time, it should meet the deadline. If it fails to meet the deadline, the life is critical, which means it is life critical application. Firm real time means it is similar to hard real time properties, and software real time means it can have tolerance in meeting its deadline. If deadline completed also, it does not affect human life. And coming to networked embedded system, it is more than one device is connected to another is called network embedded system. The examples of a network embedded system is smartwatches, drones, robots, traffic lights, earbuds, etc. And coming to mobile embedded systems, mobile embedded system means it can move from one place to another place like mobile. And a networked embedded system and mobile embedded system is hybrid embedded systems. And the characteristics of an embedded system is it is compact in size and reliability and consistency. It works in real time and it is having specific functionality. And coming to microcontroller and microprocessor, microcontroller looks like a black color IC with pins. We are having other ICs like timers, op-amps, and microcontroller is an integrated circuit that can be programmed to do a specific task. And the main difference between microprocessor and microcontroller is the microcontroller has built-in CPU, memory, and input-output peripherals. Coming to microprocessor, it is just a CPU that needs external components for full operation. That is the main difference between microprocessor and microcontroller. And coming to PiximLab architecture, PiximLab is a simulation tool that helps in testing embedded systems before real world implementation. It allows debugging microcontroller programs without needing physical hardware, making development faster and easier. Basically, in PiximLab, we are using PIC16F877A microcontroller. It is having 40 pins. It operates on the frequency of 20 megahertz, and it consists of general purpose input output pins, I2C pin, LM35 temperature sensor, ADC, CLCD, matrix keypad, SSDs means memories, digital keypad, buzzer, LEDs, and RS232. In our project, we are using some peripherals like LEDs, switches are keypad, timers, CLCD. LEDs is used for visual feedback, and switches and keypads are used for allow user input, and timers are used for counting and delays. CLDs are displays system status and user inputs. And coming to LED, an LED is a semiconductor device that emits light when current flows through it. In an embedded system, LEDs are commonly used for displaying system status like on, off, error, cooking modes, etc. The mostly used applications of LEDs are home lighting, remote controls, displays, and many more. And to interface LEDs with microcontrollers, we are having two types: sourcing circuit and sinking circuit. Sourcing circuit in in a sourcing circuit, the microcontroller provides a positive voltage to the LED's anode and the cathode is connected to ground. When the microcontroller outputs a logic high, it supplies current to the LED causing to light up. When microcontroller output is logic 0, it supplies current to the ground causing to light off. And coming to sinking circuit, in a sinking circuit, the LED's anode is connected to a positive supply and the cathode is connected to the microcontroller. When the microcontroller outputs a logic low, which means 0, it sinks current from LED causing lighting up. And coming to switches, these are the LEDs interfacing with PIC16F877A. And coming to switches, a switch is a simple input device used to open or close a circuit in embedded systems. Switches are often used to collect user input, such as selecting cooking modes or entering cooking times, like that. And most commonly used switch is tactile switch. The most common applications of tactile switch is mobile phones, computer mouses, etc. There are two types of switches: pull up and pull down. And this is an pull up circuit and this is an pull down circuit. In pull up, resistors are used when the switch is connected to ground. When the switch is open, the input is pulled up to high voltage, and when the switch is closed, the input is connected to low voltage, which means ground. And coming to pull down resistors are used when the switch is connected to positive supply, and when the switch is open, the input is pulled to a low voltage. When closed, it is pulled up to a high voltage. And this is about pull up and pull down circuits of switches. And coming to matrix keypad, the matrix keypad is a type of keypad that consists of a grid of rows and columns. It allows for multiple keys to be placed in a compact layout while minimizing the number of connections needed to microcontroller. It operates by arranging switches in rows and columns. Basically, in our project, that is, we are using PIC16F877A microcontroller. In the port D is connected to rows and port B connected to columns. And the rows are configured as outputs by giving logic 0 and the columns are configured as inputs by giving logic 1. And coming to interrupt service routine, interrupt service routine means ISR triggered when an event occurred, ensuring the system responds instantly. Or microcontroller is busy executing the infinite loop. During that time, some external devices or internal devices. External devices or internal devices will request the processor to stop the processing. Then processor will stop the processing and attend the request and come back to the process when where it was interrupted. And we are having classification of interrupt service routine. Basically it is two types: hardware interrupts and software interrupts. In hardware interrupts we are having two types: non-maskable and maskable. Maskable means it is hiding something to enable or disable. Maskable means it is not disable, it is always enable. Maskable interrupts are again two types: external interrupts and internal interrupts. External interrupts means microcontroller is interrupting due to external devices like connections from outside devices like general purpose input output pins. Internal interrupts means interruption because of inside the microcontroller devices like timers, ADCs, uh, DACs, etc. And coming to timers. Timer is the default peripheral in microcontroller which is used to calculate the time. And timers are three types: timer 0, timer 1, timer 2. In our project, we are using timer 2. And in timer, we are having some key words, that is resolution, tick, and quantum. Resolution means width of the timer register. It can be 8-bit timer, 16-bit timer, 32-bit timer, or 64-bit timer. In our project, we are using 8-bit timer which is having 256 states, that is 0 to 255. And tick, tick means incrementing the count or decrementing the count. It is calling tick. And quantum. Quantum is a time taken by a tick is called quantum. And um, scaling. Scaling, we are having two types: pre-scaling and post-scaling. Pre-scaling means scaling time taken by a tick, and post-scaling means scale after how many overflow interrupt will occur. And modes of an timer is counter, PWM or pulse generator, PW or PPM measurement, etc. And coming to CLCD. CLCD abbreviated as character liquid crystal display. In Pixim lab, there are two types of displays: 16 by 2 display and 16 by 4 display, which means it displays the 16 characters in single row. Like that, in 16 by 2 display, it is having two rows that displays 16 characters in each row. And 16 by 4 display means it is having 4 rows. In each row, it displays the 16 characters. It displays all the ASCII characters and all some of the special characters also CLCD displays. There are two types of communication modes, that is 4-bit mode and 8-bit mode. In 4-bit mode, we will send data nibble by nibble. It is same as 8-bit, but we use only 4-bit pins, that is D4 to D7, remaining same. In 8-bit mode, we will send data by byte. In our project, we are using 4-bit mode because for CLCD we are having using port D. The port D pins RD0 to RD3 are used for matrix keypad. So RD4 to D7 are used for CLCD. And coming to what is microwave oven. Microwave oven is a kitchen appliance that uses electromagnetic waves to heat food. Modern ovens have multiple cooking modes. In this project, we are going to implement 4 modes. They are micro mode, grill mode, convection mode, and start mode. Microwave mode means it is standard heating using microwaves, which means this is a standard mode where the microwave oven emits microwaves to heat and cook food. And coming to grill mode, it uses high heat for grilling. And coming to convection mode, it uses a fan to distribute heat evenly. Start mode. Start mode is a default mode that starts a 30 seconds timer. If we want to increase the time by pressing the key 4, we need to add 30 seconds to the timer. And now, and now we are going to demo of the project, and this is my code. This is main.h. In this I am including the header files. This is main.c. This is microwave oven.c, and this is microwave oven.h. I am included here the header files related to my project. This is our PIC 16FA77A microcontroller. It is PIC 16F77A microcontroller. It consists of 40 pins. It is a double EEPROM memory. It is real-time clock, relays, and here we are having cooler, and it is a buzzer. It is CLCD display. This is matrix keypad, and these are the LEDs, and these are the ports, 4 ports. And whenever I turn on power on, when the system is powered on, the LCD display shows the powering on message, indicating that the system has started successfully. After that, system provides 4 cooking modes which can be selected using the keypad. Pressing a specific key selects the corresponding modes. Key 1 for micro mode, key 2 for grill mode, key 3 for convection mode, and key 4 for start mode. To select the micro mode, we need to press key 1. It firstly displays the power of 900 watts. After that, the user needs to set the time. It asks the user to enter the time using the keypad. The user can enter the time using key 0 to 9. Now I am entering a 50 seconds, and the first 2 are minutes, these 2 are seconds. I am entering 50 seconds of time. So I am pressing 5 and 0. It indicates that 50 seconds. After that, pressing hash starts the microwave oven. And here it displays the cooking time, and it shows the 3 options: start and resume, pause, stop. By pressing key 5, it pauses, and cooler also stop. After that, whenever we want to pause, we need to click 5. After that, we need to resume this. We need to click 4. It starts again where it stopped. From that, it is again started. By pressing 6th key, it starts from first. Like by pressing stop, it shows the main menu. Again, we need to click 1. It shows power. After that, it asks the time to enter. I am entering 5 seconds now. After that, I am pressing here hash, and the time remaining is 0 to seconds. After that, it beeps the buzzer, and it shows the main menu. And for grill mode, we need to press key 2. The system prompts the user to enter the cooking time. After entering the time and pressing hash, grill mode started. Again, I am pressing 2 seconds. If I press start, it clears it. The time will be clear. I am pressing hash. It is clears the time. Again, I need to set the time. Now I am setting the time as 9 seconds. And I'm pressing the hash, the grill mode starts. Once the cooking starts, the remaining time is displayed on the LCD. During cooking, the user has three options: start, stop, resume, like that. After that, it shows time up, enjoy your meal, and again it go to main menu. After that, it shows we need to go for convection mode. To select the convection mode, press E3. Convection mode requires the user to set a temperature before setting the cooking time. The system first asks for a temperature input. Now I am giving the 250 Celsius temperature. Now I am enter the temperature and pressing the hash. The oven preheats before allowing the user to set the time. After setting the time, I am going to enter hash and it shows the preheating time and time remaining is 60 seconds. After 60 seconds, it is asking preheating and time remaining to cook. By defaultly, it is showing 60 seconds because defaultly I am setting the delay time remaining as 60 seconds in my code. So that's why it is showing from 60 seconds. After this time end, we need to enter the time, which means user need to enter the time for cooking. After that starts, the cooler starts rotating and after time becomes 0, the buzzer also beeps and it LCD displays the time is up, enjoy your meal. So, time remaining becomes 0. We need to enter the time. Now, time remaining is 0 and it is showing the user need to set time here. Now, I am setting 50 seconds and I am pressing hash. Once the cooking starts, the remaining time is displayed on the LCD. During cooking, the user has three options. Press key for resume cooking, press 5 for pause the cooking, press 6 for stop the cooking. Now I am clicking the pause. Now the cooking is paused, the cooler also stopped. Now I want to resume it, so I am clicking the 4. After this 30 seconds, we need LCD displays the time is up, enjoy your meal with beep sound, with buzzer sound like beep. We need to wait until it becomes 0. Until we need to wait until time equals to 0 seconds. Then only our cooking will be completed. Then it shows the time up and enjoy your meal with buzzer sound. And cooler also stopped. Time up, enjoy your meal with buzzer sound. Again it go to menu bar after completing the convection mode. After that we are having start mode. For start mode we need to press key. This mode starts the microwave for 30 seconds by default. If we press 4 again, it increments the time by 30 seconds. So for start mode, we need to click 4. It defaultly shows the 30 seconds. By pressing 4, it increases 30 seconds again. By increases 30 seconds again. And it is same as micro mode, grill mode, convection mode. So I am going to 6 to stop this. And this is about my project of microwave oven simulation. This concludes the demonstration of my project. During this project, I learned embedded system programming, microcontroller interfacing, working with timers and keypads, building a real-time application in an embedded system. Thank you.